Hello everyone, welcome to the Setfos tutorial. To this series of design of passive thin film optical structure. It is a third part of passive optical properties simulation. So in this tutorial we are going to simulate multi-layer coatings and angular reflecting spectra. We have already discussed about the anti-reflection coatings, total internal reflection and plasma resonance sensors. So before start of the tutorial, I want to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. We have already discussed about the company features and their services. So in this tutorial, we are directly jump to the presentation parts and then perform our tutorial in the Setfos tool. Before we start the tutorial, we want to tell about the multi-layer coating and angular reflectance spectrum. So you can easily understand what I want to perform in the Setfos tools. Multi-layer coating is a technique that involves stacking multiple thin film of different material to create a customized coatings. The layer can be made of various materials such as an inorganic layer like aluminum oxides, titanium dioxides, and silicon dioxides, or covalent or ionic material like boron carbide, silicon carbide, and silicon nitride aluminum oxides. You can see it here the diagram. So these are the layer structure. They can be different materials. So incident light comes and the reflected light combination of the 8 beams. It can be a high refractive index and low refractive index. So it is a combination. The most important term come across at here, distributed Bragg reflectors. It is a multi-layer structures that reflect light with high reflectivity at specific wavelength. And angular reflectance spectra is the variation of reflectance at specific wavelength with different wave and incident geometry. So what angles make at here, you can easily put in the Setfos, and different geometry you can find your angular reflectance spectra and graphs that you want to see. So now I'm going to start our tutorial in the Setfos. Click at right sides and run administrator. Who has not seen it my previous video, please check out the playlist, because in my previous video we have already discussed about the Setfos tools and their modules and how we can use Setfos tools. It is examples and these are the Setfos tools. So for the create a new simulation file, click at here. If you want more layers, so you can add use of the plus I symbols. We are going to create it at here multi-layer coatings, as it term means that widely used to fabricate high reflectivity coatings where a sequence of high and low index materials are employed alternatively. So at the term distributed Bragg reflector, it is a made of multiple layer of dielectric materials with high and low refractive index. The layer thickness must melt the quarter wavelength condition at specific wavelength. So now I'm going to consider it here air. It is illustration of multi-layer sequence for distributed back reflector with high or low index layer. So firstly we are going to consider it here high index materials. So it will be titanium dioxide. I'm going to consider it here 4 pair. Second one is low index material. It is a silicon dioxide. Alternate manner you can consider it here. I have already told about this. You can add more layer. Last one is glass. At here the showing duplicate layer names. So we are created at here 4 pairs. You can give name. 1 1 2 2 3 3 and 4 4. High index and low index alternate manner layer are created at here. Now we will be provide at here thickness 0.25. It will be same. Top and bottom layer are semi-infinite medium, so thickness are irrelevant at here. The layer thickness must be quarter wavelength condition at specific wavelength. Now I am going to consider at here high index and low index materials. Refractive index of the material put 1 by 1, 2.75 for the titanium dioxide and 1.455 for the silicon dioxide. So similar for the each of the layer alternate matter we will be put. For the titanium dioxide it will be 2.75 and silicon dioxide it will be 1.455. We are calculated in here passive optic properties, so these tool need to be active and they are already active. The reference and design wavelength is 550 nm and incident angle 0 degree, and shift wavelength we need to vary at here. It totally depend on you which value you want in here, and step it will be same one. We need to activate here shift mode because we are going to shift incident angle at here, and they will be shift at from 0 to 60 with step 60 degree. At here layer structure are completed, passive optic settings also completed, and shift settings we have considered at here incident angle and they can be changed according to you. Now you will be give the name of the simulation file, multi-layer coating. That structure you can see at here. Click at play button. Optical profiles are given at here, refractive index and passive optic properties are given. You can see at here one by one. Reflected color, solar integrated absorption. We are not imported at here refractive index files and absorption modules are not active, so the result are not showing at here. If you simply click at here the play button, you can see at here the variation for the transmittance. If you click at here the play button for the wavelength variation, so you can see at here the reflectance. If you see like this, you can see at here the clear image. A normal incident, the reflective spectra of S and P polarization coincide as expected 0 degree and 60 degree for the X polarization and reflectance spectra for the P polarization. Polarization dependent reflectivity spectra of distributed back reflector mirror at angle of 0 degree and 60 degree for the S polarization and P polarization. If you click at here, you can see. So I hope you understand how we can create multi-layer coatings and angular reflectance property we can got. Now I'm going to end that here my tutorial. If you have any query related to this, you can ask in comment box, and in the description box email are also given. If you want to book demo, you can check our company website impulsetechnology.in, and who has not seen it previous video, please check out the playlist for the more details. Thank you very much.